Hello guys, welcome back to this video. In this video I'm going to I'm going to explain how we perform a second order CFA. And the concept of second order CFA is clear. I'm going to practically show how to apply this concept in C using AMS and CFA. Basically, if there are two variables having a really high correlation with each other, in case of variable B and variable C, over here we have the correlation between them is 70%. And the first thing is, if there is no way to modify the model any further, and you cannot decrease the value of correlation between these two variables, and in a way which violates the concept of discriminant validity. So another solution is that to run a second order CFA. What is the second order CFA basically tells us? That tells us that so the correlation between these two variables, variable A, variable B, and variable C, is so high. It means they serve as a one variable, and so that is why we are going to perform a second order CFA. And how to do it? Let me just show you how to do it practically in AMS. First of all, we have to delete all the relationship between these variables, and we are going to create another latent variable between these two variables, latent variables, which are correlated highly, and the correlation value was approximately 70. It was 70, which is quite high. So that is one of the justification that why we have applied second order CFA. That's because two variables are really correlated, highly correlated. So that's why it required justify would suggest to perform second order CFA and draw the variables between these two, because we have created a common variable and representing these two latent variables which are highly correlated. And then the second thing I would like to do is to correlate this, then run analysis. Okay, so the model is not the analysis did not run because one of the path over here is not constrained. So I'm going to constrain the model over here and give it a parameter which is 1. Then it's going to run. Yeah, the model is run finally, and you see that now this time our second order CFA is completely okay. So we don't have that high correlation between these two latent variables. Actually, this latent variable represents these two latent variables, and we have correlate these two latent variables for the sake of correlation. So here we don't have that much high correlation. It is 69. So in this way we are going to perform second order CFA. And so here is the CFA is completed, and this is the second order CFA. Let me just check out the estimates. Analysis is also easy, and just we are going to draw or delete this relationship, because in the path analysis we don't have the relationship, two ways relationship. It is only one way relationship. And now I'm going to see the effect of these two variables on variable A, which is my dependent variable. So instead of checking individually the effect of variable B and C on A, I'm going to check the effect of BC on A, because we have run the second order CFA. So So I'm going to bring this into, okay, I'm going to bring it a little bit here, and I'm going to rotate this, and I'm going to draw one. This is the path, so we are going to do some kind of path analysis, and so this is a regression in case of like we call it path analysis in terminology of AMS. So it is like similar as regression in terms of species. I have drawn this path. It means I'm going to see the effect of BC on A, variable A, which is my dependent variable, and I'm going to create some error term because the amount of variance, or the values, the variance explained in the dependent variable by variable BC will be demonstrated on this, and here we will have the error terms. So I'm going to draw unobserved variable. Now the model is okay. Let me just run the analysis, proceed with the analysis. Oh yeah, that's quite good. Let me just see the effects. You see, it is the effect is quite high. This is 69% of variance explained in the latent variable by our independent variable. And let me just check over here. This is, and we have run the analysis, and this is look at the analysis, and it is quite significant, and the impact of BC on A, variable A, is around 69%.